Okay, this is a video about one application in stoichiometry of Avogadro's law. To review Avogadro's law, this is from the gas laws, and it says that when you have equal volumes of gas, they contain equal particles or equal moles. So if I have 1 liter, 1 dm cubed of hydrogen, and I have the exact same volume of oxygen, then they have equal moles. The moles of hydrogen is equal to the moles of oxygen. The masses would not be the same because oxygen is a lot heavier than hydrogen, but the number of particles and therefore the number of moles is equal. And we can take that and apply it to chemical equations and stoichiometry, where we're looking at mole ratios, because if the moles and the volumes are proportional, then the mole ratio is proportional to a volume ratio. Okay, so what does that mean? Well, in this reaction here, I see the mole ratio is 1N2 in the gas phase. So this is only applying, of course, to gaseous reactants and products, this law. So 1 mole of nitrogen reacts with 3 moles of hydrogen and creates 2 moles of ammonia. So the ratio, the mole ratio is 1 mole N2, 3 mole H2, 2 mole NH3. Okay, if we think of our molar volume of a gas at STP, we know that 1 mole takes up 22.7 dm cubed. So if this reaction is taking place at STP, and we had 1 mole of nitrogen, then the nitrogen would take up 22.7 dm cubed. The hydrogen would take up 3 times that much space, 68.1 dm cubed, and the ammonia would take up 2 times that much space when it's produced. So it would take up a volume of 45.4 dm cubed. If we simplify those numbers down, at their core, those numbers are 1 to 3 to 2. That's a 1 to 3 to 2 ratio of volume. So what we're seeing is that if the mole ratio is 1 to 3 to 2, then under the same conditions of temperature and pressure, the volume ratios will be 1 to 3 to 2. And basically what this does for you is it means that they're going to have problems on the IB exam where they give you information about reactants or products, and they give you that information in terms of volumes, and you never have to bother converting into moles. This allows you to sort of bypass the typical stoichiometry approach where normally you start out with, let's say, mass, and your first step will be to convert into moles. Then your second step would be to use the mole ratio to go from, information about compound A to information about compound B, and then you might convert back out to mass. So usually stoichiometry questions sort of have this 3-step process: converting into moles, applying the mole ratio, and then converting out of moles. The nice thing here is that when you have volume of gas and you want to know about volume of gas of something else, so this is of A and this is B, yeah, you could use the ideal gas law. You could go into moles, use the mole ratio, and then go use the ideal gas law again to get back out to the volume. But this gives you like a bypass. It gives you a shortcut. So you can just use the mole ratio, the same mole ratio that you would use for moles. You can use the same mole ratio to just go from information about A to information about B without ever having to do the mole conversions. Okay, let's see what that means in practice. So this would be a question for this reaction that we have up above. I'm going to clean it up a little bit. Okay, it says we have 1.2 dm cubed of nitrogen, and it's mixed with 6.6 dm cubed of hydrogen to produce ammonia at standard ambient temperature and pressure. Determine the limiting and excess reactants. So we would approach this just like if this dm cubed had said moles, and if this had said moles. We're going to do the work the exact same. So 1.2 dm cubed of nitrogen, and we're trying to figure out how much ammonia we can make. Well, the mole ratio is 1 nitrogen makes 2 ammonia. So if I apply this ratio, I have enough nitrogen to make 2.4 dm cubed of ammonia. Okay, that was reactant number 1. I would then also check the hydrogen, 6.6 dm cubed of hydrogen. The ratio is 3 hydrogen make 2 ammonia. And so I have enough hydrogen to make 4.4 dm cubed of ammonia. Okay, and then, then it's just like any other limiting excess reagent question. I'm going to choose the smaller amount. So this is the amount I actually make. So the theoretical yield of ammonia is 2.4 dm cubed. I don't actually make this amount. That's too big. Clearly my nitrogen would have run out. So I would say my limiting reagent is N2, and my excess is the H2, because the N2 made less, the H2 I must have extra of. And the last question, determine the volume of excess reactant that's remaining. That tends to give people the most trouble. Again, it's got to be based on the limiting reactant. So I know that I only had 1.2 of N2, and I've established that's my limiting reactant. It reacts in a 1:3 ratio with my hydrogen, so I can figure out how much actually got used. So I actually used 3.6 of my hydrogen. I started with 6.6 in the first place, so that means I have 3 dm cubed hydrogen left over. So that's my excess hydrogen. So with all these questions, all we're doing is using mole ratios, and we're just applying them straight to the volumes. And so if you are aware of Avogadro's law, this gives you a really handy shortcut when you're dealing with gaseous volumes in these stoichiometry equations.